Today we're starting with the second part of 4.5, first and second derivative tests. Before, we just assumed that f of c was equal to 0. Now we're taking the first derivative, setting that equal to 0, or sorry, taking the derivative of that to get the second derivative, and finding out the relative maxes and mins. All right. Let f of x equals x cubed minus 3x. We're going to use the second derivative test and find any relative extreme values. Just like before. Find the first derivative. Nothing's changed. Find the first derivative. The first derivative is what? 3x squared minus 3. Okay. For these, it's bad. Actually, it doesn't matter which way we do it. I can try to factor it, or this one I can set equal to 0. I'm going to try to factor it. I pull out a 3, and I'm left with x squared minus 1, which I should know is 3 times x plus 1, x minus 1, which means I have a 0 at negative 1 and 1. Yeah, if I would have set this equal to 0, 3x squared minus 3 equals 0, add the 3 over, 3x squared equals 3, divide by 3, x squared is 1, take the square root, x is plus or minus 1. Same thing. This works sometimes a lot faster. The 3 out front means nothing here. It is just a coefficient. Because it would just mean 3 equals 0, which is not true. Right, there's no x value. If there was 3x, then I do use the 3x. I'm going to take the second derivative. What's the second derivative of 3x squared minus 3? 6x. This is what the second derivative test does. I take the second derivative, so it's 6x. Take my 0 values. Substitute them in. This comes from over here. I substitute in the negative 1 and I substitute in the 1. So I have negative 6 and I have positive 6. Second derivative. The derivative of 3x squared minus 3 is 6x. If this is less than 0, and this one is greater than 0, if it's less than 0, it is a relative max. If it's greater than 0, it is a relative min. It's a shortcut so I don't have to do the plus minuses. Here, if we would still do the plus minus. Yep. The only downside is second derivative test doesn't always work. This doesn't always work. You'll try to take the second derivative and you can't do anything with it. I'll show you. Now for this, I'm going to do it the old way. This is just the old method. X plus 1, x minus 1, and then the original was 3x squared plus 3, right? Minus 3, I'll fix it. Add 2 zeros. This 0 was at negative 1 and 1. That's a 0. That's a 0. To the left of this one, it's negative. To the right is positive. To the left of this one's negative. To the right is positive. Negative times negative gets me a positive. Positive times a negative gets me a negative. Positive times positive gets me a positive. Goes up, goes down, goes up. -1 is a relative max. Same thing as up here. 1 is a relative min. Same as up here. If you substitute in your zeros into the second derivative, if it's less than 0, it's a max. If it's greater than 0, it's a min. Try this one on your own. Find the relative mins, maxes, whatever. The first derivative is what? Now here can't really factor this one. This one I'm going to set equal to 0. If I set it equal to 0, x ends up being 3/8. I take and find the second derivative. Second derivative is -8. All right? F double prime of 3/8. If I put in 3/8 for x, what do I get? -8. -8 tells me it is a... Right, so what's F double prime of a million? No, -8. No matter what, it's always going to be -8. -8 is less than 0. Less than 0 means it's a relative max. Because this is less than 0. Now this one here, I'm going to show you on the chart. My only zero is at 3/8. -3 or 8x plus 3. This is a 0 right here. If I pick a number less than 3/8, give me a number less than 3/8. 0. And that gives me what type of number? Well, 0 plus 3 is positive. If I pick a number greater than, it's going to be negative. So it goes up and then down. That's a maximum. This is why I've never really told you everything to the left is always going to be negative and to the right is going to be positive. Why is this different from the ones in the past? No. Fraction means nothing here. There's a negative in front of the variable. Negative in front of the variable would flip what you normally think. On these ones, it wasn't a negative x. So it just was normal. And the other ones aren't on there. Let me give you one. F of x equals 3x to the fourth minus 4x cubed. Try this one. All right, on this problem, first derivative, I get 12x cubed minus 12x squared. What can I do here? Take out a 12x squared, and I'm left with x minus 1. So I have a 0 at 0, and I have a 0 at 1. There's only 2. Okay. Now I take the second derivative. 36x squared minus 24x. Substitute in the 0, substitute in the 1. Let's see. 0 minus 0 gets me 0. This one has 36 minus 24, which is 12. I have a problem here. This is greater than 0, so this one is a relative min. This one here is equal to 0. It causes me a problem. It has to be less than 0 or greater than 0. This is the one this is why the second derivative test doesn't truly work. Okay, this is a relative min. So that means my graph comes down if I have my xy. At 1, that down wherever it's at, negative 12, or at 12. It's a minimum. But at 0, something weird happens. Doesn't break. It's coming down. Like something like this. It's not perfectly smooth. It's not a minimum, it's just like a little slowdown period. Do you understand? It's not a minimum, something weird happens. It's not a max or a min. It sort of levels out. It changes its slope at that point. That's the only part where the second derivative test doesn't work, is when it's equal to 0. Questions? There's nothing for this one.